Right? We should be up. So I'm going to re-implement my game solver in Rust. My game solver, which is here. I have a nonogram solver, and it pretty simple really. It goes and it takes a list of, so basically nonograms, right? So the idea behind a nonogram is that each number tells you the chains of something, of like pieces filled in that row column. So for example, this says 10. So clearly in this row there's all 10. Now, this says 6 and 1, which means that there's going to be a 6 and then a 1, but not necessarily there. It could be like this, could be like this, you know, it depends. But the point is that there's a solution to these, and you're supposed to figure out how to solve them. And the general strategy is you look at this and you say, well, no matter what, these pieces are going to be filled in, right? And you can look at this and say, okay, well, this is a 4 and 1. This is clearly the 4, right? So something like that is how you would generally go around and solve these. You could also look at this and say, I don't know. From here, where do you go? You'd go 2, 7, right? That's only one possibility. These are clearly then, you can look at the fact that these are all 1s, etc., right? Then you would go and look at this. See, this is 1, 2, 1, 2. So clearly, actually, that one's not very clear. This is a 5, 1, 1, so this is obviously the 5. One of these is the 1. With that said, this 6, 2, ooh, it's a little tricky, but I would say this is always filled in. With that said, 1, 2, this is either one of these are filled in. You would have, must be like this then. Okay, I've already messed up because that's not possible. But anyway, the point is I could go and feed this into my solver and it would tell me what to do, right? So I'll run it. Kotlin compile times are actually garbage. I mean, wow. Anyway, enter row chains, which mean these. So 9, 1, 7, 6, 2, 10, 3, 1, 3. Right, this is how I did it. 6, 1, and then 1, 1, 2, 1, 2, 7. Then the column chains are 3, 2, 1, 1, 2, 1, 2, 1, 2, 1, 2. No, 1, 2, 2, 1. 4, 3, 1, 7, 1, 5, 1, 1, 2, 2, 1, 2, 1, 1, 4, 1, 4, 1, 2. And there you go. It gives you the solution. Brilliant. But sometimes it gets kind of deep and it gets kind of slow, right? And that's not what I want. So we're going to redo it in Rust and hopefully it's a little faster. So let me turn up my brightness. So cool. So it's all good. And now let's get started with a pretty much direct translation. We'll have a, none of this matters. We'll just have it be for now a, probably a hard-coded thing. We can just make it what we had, but whatever, we won't do that. Let's make it a, all right, so, yeah, I mean, I guess main isn't necessarily a good place to start. But we might as well do ask chains. So for that, we'll need to use stdio standard in. Am I? or just stdio, and then we'll this returns a result or what? Nope, that's standard in always. Right, so this should block. Just to be sure that everything's working. Alright, you give it a mute string, so I don't know. So it's a little bit, if I'm not mistaken. Or you do dot unwrap to basically, I mean, that's fair enough. Right, so pretty easy. Fn ask chains, which returns a vector of integers. Those should always be positive, but whatever. Now we will do this. So we will have basically this code. Let's call it line. We're gonna take line, trim it, dot map our string into string, of course, iter. Of course, I forgot to split it. I would explain it. So again, this is not the greatest design, but whatever. For now, it's good enough. I'll probably refactor it later. Alright, anyway. String dot I'm just gonna allow spaces. Map it dot parse as a u32. Right, and then you have to collect it. So collect this, there, now it should work. Of course. I'm gonna make this an unwrap. First struct. Of course. The unwrap should go here. Now it should work. There we go. So not too bad. Print line, enter, row chains. All good. Now we'll just right. Row chains call. Oh, I would hope so. Dot solve. Right, so like this. Now we're going to want oops. Board solver use use board solver. So just to make sure this works, we make a struct board solver. And probably a pub struct board solver, in fact. Alright, all good. So now I can see this and deal with it. And just to be sure, let's do a just to be consistent, I'll put this in here. Now we should be good. So clearly we need to implement some stuff for this. So let's make a new. Return self. Now, what is in this? Right, it has row chains and call chains. So again, let's just use U32 for basically everything here. All good. Now we'll do a bit verbose here, but it's whatever. It should now own the row chains and call chains. There we go. So yeah, always a little bit verbose to do something like that, but it's Rust. Now we want to function solve, right? Which takes maybe mutable reference to self, but I'm not sure about that yet. So we want, now this is where we can do some nice stuff. We can do enum, probably above. Yeah. So we have either it's a success with a board of optional pieces, or, and we're going to get to that because right now it's not loving that, it's board finished with board of optional pieces, or it's a unsolvable, or it's stuck, right? So to get this to stop yelling at us, we're going to need to oh my gosh, can this please shut up? All right. So then board was generic over T. And it had a property rows, which is a vector of T. All right. So info board. There we go. Now we want an fn new, obviously, which takes rows and returns, I mean, self with rows, return type self. This should be public. Getting used to writing that a little bit. Now, we want width, right? And that's just going to be a U size. And that's basically just, it's going to have to take self and return rows dot self dot rows dot length. And then, actually that would be height, right? Width should be self dot rows dot first. I mean, there should really be a oh, just to be safe, let's match self dot rows dot get 0. row.len. Dude, I don't want to make this return an option. I don't know, it should actually be fine. All right. All good. And I'm sure you could do this with like mapping and then unwrap or, but I don't really want to. Now we have, okay, column should absolutely be a getter. Do you ever need this really? Calls? Oh, I never actually use this. Or do I from board solver maybe? Ah. No, that will be fairly useful to have, so um alright, fine. So it'll return a new vector of t. And so it should return so then here's the issue is that I could just force t to be a copy type and that will make my life easier because I'm only going to deal with booleans and options and stuff. Assuming options are copy. Let me test that real quick. Let x equals Alright, all good. They're copy types. So I'll probably keep it on this for now. Okay. Use creates board. All good. And then we're going to want to use piece. And that obviously does not exist yet because we have not declared it. We want to do that. Make a piece.rs and I'll get to it, but first I need to fix this. So calls is going to return the whole thing as a column. So let me think, how did I do this? I took the numbers and then mapped each one to the row. Yeah. That probably won't let me do that, right? Alright, because it's a copy type, that's why it's allowed to do that. Dot map x, right? That's the x. Now, rows.mapit.co. Um, that's a really a vector? I mean, no, there's no way this is fine. This must just be filling because this, right? Because I mean, really? Is this okay? No. That can't be right. There's something up here with my checking. What? How is this all right? Yeah, this shouldn't... You'd have to collect it. I mean, come on. Yeah, there's something up with the type checking here. Might be because of this. If I just remove these, we should be fine. Yeah, okay. But earlier, if I'd removed this, that would be dead, right? Yeah. Well, that's interesting. Um, it should be fast enough is all I'm gonna say. Like, it really should be. All right. Yeah, okay. Now what else was there? There's set right. So this I'm I don't love this. First of all, set row is already like pretty obvious. This is all because I was using this copy on write stuff, but I don't want to do that. I'll just make it derive clone, but not copy, please. Clone. All right. So we want to be explicit about when we're cloning it. Okay, assert that the call then is equal to the size of the thing, right? Which is the height. All good. Now we want this to be, well, you know, you would go through indices, I'm sure. No, no. Uh, self dot rows x, y. Ooh, no, this should be y, x equals. No, this should be enumerate. Oh, dot. Why is this yelling at me? This should be then the val. All right. So t is clonable, so we can just move out of this. All right, all good. And that should just about do it. Right, because this is the should be fine. Should be fine. Set val. Well, that's already pretty easy enough to do. I'm not gonna do that. Right, toString. Right. So I don't need that because it'll just be debuggable. Right. So I'll make a derive clone debug. Right. Now we want a function of. Ooh. Alright. Pubfn of, which takes. Ooh, okay. The height is going to be usize, width is going to be usize, and then it's going to take f, which is pubfn of, which takes an f, where f is an fn once. Ooh. Is this how you did it? And then t? I'm praying. fn once trait rest. I mean, okay, this isn't helpful. I could just look at any function basically. So like option rest, like map, for example. Excuse me. All right, map. FN once should be good. Should be fine. Oh wait, but we don't want it to be an FN once. We should just be an FN, which can be called multiple times, right? Because this is going to be called multiple times. Actually, FN once might be good enough for that. We'll see how it goes. We'll see how it goes. Right, so if I call, oops, F. Okay, so that's not good enough. FN maybe? And if I do FN mute, that'll also fail. Awesome. All right, so we'll do this, FN. And then we'll just have board, ooh, there must be a way to do vector dot of, fill vector with function. I don't love that. No, but then you're computing. I mean, technically that is better, so I'll just take that. And it can do type inference here, so that shouldn't be too bad. Right, so this returns self, where rows I mean, I can actually figure this out once I use it, right? So I'll have to do 0 through height dot map y height 0 through width dot map please work. Yeah. Nice. Brilliant. It's a little bit ugly, but it is what it is. I mean, what can you do? What can you do? That's whatever. That's fine. I don't even hate it. Alright, so now there's basically a translation of everything we did in Rust. Now, piece will be easy to implement. Alright. So construct piece. I mean, it's just a Boolean. So, right? And then it's either, of course, this should be enum. It will have the same representation, really, but literally exact same representation. But we can do some cool stuff with it. So first of all, I'm going to derive debug, clone, copy. Now, okay, now this thing shouldn't yell at me once I try to uncomment all this. All good. Okay, so I'm gonna override then implement debug for this. Yeah, I will. Impl debug. Impl debug. Now I'm just gonna check Stack Overflow. I trust it more. It takes fmt standard family. Oh, good. So then let char equals match self empty full. All good. Now we just hit the char. But also I will make this a nice little. It's the same as one of. Oh, all right. Almost forgot. There we go. And then just this should be good. Cool. So that should work. There's our debug implementation, which is a single character. All right, fn random. So for this, we're gonna actually need to do cargo add rand. If rand random empty else. Nope, that doesn't make sense. All right. So then we have the get change. Now the nice thing is finally, oh wait, actually, maybe this isn't. We could make a phantom struct, but I guess there's a reason you're not supposed to be able to do it. I'll just make a like that really shouldn't even be here. So I'll just move it somewhere else. This is really all you need. And by the way, this should still just be 1 byte because it'll just use a different discriminant, right? So instead of 2 possible things, there will be 4 possible things. And it can figure out what it is. Or maybe even there's only 3. But either way, it's 1 byte, right? So that's unlike all the fanfare that you have with like a whole 64-bit pointer in a JVM language, right? All right, so I'll move this somewhere else. Board solver, now that's the tough part. That is the tough part. I already had it added. Let me just see how fast it compiles nice and fast. Does it? Okay. And then that too. So clearly right now, it sees this, but that doesn't do anything. So solved, and you get the unit type back, which is nothing. I don't hate it. It's whatever. Also, I'm going to pretty print this. There we go. All right. Right. Now, the fun part. Blank board. Alright. So then Well, might as well have let's put this underneath. Chains dot len self dot call chains dot len, and then a function which returns board dot random piece random. Wait a sec. Why do you even need this? Oh no. Okay. I was gonna say. Hold on. Optional piece. All good. Okay, I mean it's a little bit it's okay, whatever. Now cycles. We could just do this. Does this thing even have any other cycles? Is a U32. So let's set it to 0. Right. Now this is just so much more elegant. I mean, look at this. Absolute. Whew. So we have now this. Now the tail rect, don't worry about it. I don't think it actually will affect performance because I mean it would have overflowed anyway, right? So we have then solve. Board is generally equal to a blank board. Yeah, we'll just do this. Hold on. No, I have a better idea. I'll just have a solve and solve with, so. It's a board of optional piece, which is it's basically its state. Does this even take any state, like self or anything? No, no. It will. This one will probably need to take self, but I'm not convinced that this one will have to. Because it doesn't. No, I'm just gonna make it take. I don't really care. It's probably good. Or better yet, this could maybe even take self, but I'm not sure about that yet. I'll look at it when I'm done. Is my like camera cut off or what? Alright, whatever. dot solve. Nah, I mean, taking self just doesn't make sense. Um, anyway. Okay, there's gotta be something better. So board solver. And then this whole depth thing is just a debug, so but whatever. Of course. That should work. Found mutable reference. What shouldn't this work? Maybe. That's not going to be good because then you have a mutable and immutable reference at the same time. Okay. With that in mind, maybe this shouldn't take it. You know what? I'll just keep it as this. Although obviously this should be a reference. Oh yeah, I'm stupid. No. Of course. This should take a board. But it's like, what even is this then? Right, so that's kind of the current state of it at the moment. Although maybe that should be here. No, no, no. But then won't this be dropped while still? I guess not. All right. Maybe it should take the board. I'm not sure yet. We'll get to it. To watch it over surprise they wouldn't want to watch another innocent elegant fall into the magnificent light of adults. Oh. Wow. So this stuff though is very interesting. Kind of. Right. Well, I guess we'll just translate it then. What the heck did this thing even do, man? I completely forgot. What was it? Sell list combos even? Oh, right, I remember. Yeah, of course. This is kind of like whether it's known, set, or unknown. Basically, I mean, all right, sure. Right, so this is quite the mouthful of right. I still haven't figured out why this was necessary, but whatever. Whatever, I guess. Equals state dot n minus change dot. You gotta be kidding me. This should probably be references. If I told it this, though, I could figure that out. Not even then. Alright. Now I can figure this out. What? Hold on. What is this? Oh. Right. Oh my goodness. My goodness. But dude, this shouldn't even be a... You know, I'm just gonna cast this to a... You dirty... Uh... This is so stupid. Alright. Dude, why is this a U size, man? Alright, you know what? I'm just not gonna touch it. I'll assume it's fine. Alright, so there's kind of a cache going on here. So this should be part of the state of the thing. That takes a and returns a takes a list of integers. So this is kind of to avoid the computations and everything. Wow, that is quite the thing I was definitely thinking there. I mean, you're doing so much cloning. I'm just gonna ignore this for now. Oof, what was I thinking? All right. Anyway, this is the part that really matters. And then the dot filter, so my goodness, what was I thinking? Whoa, 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 whoa. Dude, this gotta be whatever I was thinking here is not sane, but whatever. target equals 0 and path.len equals in result.push path. Whatever. Okay, else. Nope, just else. Oh no, it is an else if actually. Else if target grade is positive. Alright. For I and 0 through. Okay, backtrack. Alright, this is driving me crazy. I'm just gonna. Right, it needs to know this. Can't this thing be recursive? Right, because you have to. No, this is just stupid. Dot clone. So clearly this is just bad code. I'll look at it later. I gotta go now. But I will be back.